All right, everyone, we are back and we are going to talk about today a very, very important theorem, which is Bayes' theorem. So before we get to that, though, I want to kind of clarify certain kind of notations that we've been using, but I want to explicitly define or kind of add verbiage to kind of what we've seen previously. So obviously, probability of A is just the probability of an event A occurring. But if you see kind of this symbol, probability of A, and then this symbol again is, we've kind of mentioned it. We mentioned it previously, but again, I want to add some, a little bit more, some clear verbiage. So that's the intersection. So again, that's like an and. So this, you can kind of read this as, probability, so prob, that A and B are occurring. So that's kind of the key distinction there. So that is, that is very, that hopefully is a little bit more clear, and we know essentially what's going on here. Now, if we have this symbol, again, that's, I always want to do U, because my brain, I know it's union. So if we have this symbol right here, that is probability, prob, of A or, not and, or B occurring. So we've kind of seen that, and we've worked through that previously. So that's kind of like an or, right? Now, we've recently introduced this. Now, the order here, again, change the verbiage slightly. So here, the way we read this is probability of the first, so probability of A occurring given that B has already occurred. And if we flip it, all it flips is the reverse. So probability of B given that A has already occurred. So I just wanted to kind of make that clear because we're going to get into a pretty interesting example today with Bayes' theorem, and we're going to kind of get moving with that. So again, if we have, and we kind of mentioned, if we have multiple mutually exclusive events occurring, oftentimes it can get messy looking at those probabilities. So we may often invoke essentially this rule of elimination or rule of total probability, and write a total probability considering these mutually exclusive events occurring, like so. And we can further generalize it by invoking Bayes' theorem, where some probability here of a specific event, a specific mutually exclusive event B occurring, given that A has occurred. So we can write it essentially as this. And again, there could be multiple of these events, but if we want to calculate that specific event, then we can kind of look at this. So again, summation is, it's just a summation. So whenever you see this, again, it's often, I find that students, and I found when I was a student, that summation sign can give people consternation. But it really is just adding essentially those events up. So we'll work on that together, and we'll see kind of what's going on here. So as I drink my water, let's see if we can pull one more card out of our sleeve to get one more example. It's a horrible pun. So let's look at this scenario. So I have a card. So a card is lost from a pack of 52 cards. And then from the remaining cards, two cards are randomly drawn and found to be hearts. And we want to calculate what is the probability that the last card is also a heart. So let's try to unpack this. So we are trying to figure out what is the probability that the last card is also a heart. So what is, so when we look at this, or our Bayes' theorem, we have some probability of multiple events occurring B, and then given something that happened A. So our A, we're given that what? That once we lost the card, there basically from the remaining cards, 2 were drawn and 2 were found to be hearts. So we had basically our, I think pause with me for a second. I think we may have been frozen. I think it'll happen soon. Maybe. I click something, or let's go ahead right here. Let's go to draw. Excuse me, but you know this is live. You may skip over here. Let's see if we reload here. And are we back? Are we back or are we not back? Uh-oh, did my battery die? Draw. Let's draw. My apologies here. Yeah. I think we may be out of battery. Let's check it out. Let's check what does our pin look like? My apologies for this. Let's go ahead. See if we can simultaneously charge this guy and write. Let's see, recharging mode. There we go. Yep, my pen did die. All right, I'm I'm in the office and I'm lifting it for dear life. Let's get this guy a little bit closer. All right, so we have. Actually, excuse me here. Not that. So we have now A is our event. Effectively, that we have two cards that were pulled and they were hearts. So that's our given. So what are our other B events? Well, that the last card, we can say that the last card is a heart. That's one possibility. We can say our last card is a club. We can say, let's see. We can say B3 that our last card that is drawn is a diamond. And we can say before that our last card. Actually, let's do this is spade and this is diamond. Let's do last card spade. I'm just trying to keep track with this. And our last card is diamond. So these are the different possibilities or the events that can occur with that last probability. So again, we lost a card from Pack 52. From the maining, we drew and they were hearts. So we need to figure out what's the probability the last card is also a heart. So we need to start to set up our probabilities here. So what is the probability that we have B1? What's the probability that we can pick that the last card is a heart? Well, remember, what's the scenario here? It's just a card that's lost initially out of the 52 deck. So the probability that's a heart is a fourth, right? And that's the same probability that holds. Let me see if I've got enough juice in the pen. Okay. Let's say, and that probability should be the same for clubs, right? And the same probability for spades, and the same probability for diamonds. Because again, the card is just lost at the beginning, right? Like it has, I mean, we have equal probabilities. They're a fourth, because we're looking at essentially the type of that card, whether it's a heart, club, spade, diamond. So hopefully that part is a little bit more straightforward. But now we have to consider the following. And this is where it can get a little bit more difficult. We have to think about, well, what is the probability, right, for example, B1, given that A has occurred? So that's actually a very good question. So given that A has occurred, So what is that probability? Oh, excuse me. We're going to write it in the opposite way due to our Bayes equation. So what is the probability that we can draw A given that like B1 has occurred? So given that the card that was lost initially is, for example, a heart, what is the probability that we were able to draw 2 cards from the deck randomly and they were both found to be heart? And is a critical factor here because we're randomly drawing, it needs to be 2 hearts. So heart and a heart. So again, let's break this down one more time. What is the probability that that once a card is lost and that card that was lost is a heart, given that card that was lost is a heart, what is the probability that from that remaining deck I'm able to pull 2 cards and both of them are hearts? And is the key thing here. Previously, if we had the or, so for example, if it was, like this, probability of, or, we added. If it's an and, we need to multiply. So, given that lost card, right? So, once we lose the card, how many cards are left in our deck? 51, right? And we know that the one card is a heart. So what's the probability now that I can draw another heart? Well, there's 13 of a pair, right? So now it's just going to be 12. And if I pick that, there's only 50 cards left. What's the probability that I pick another heart? 11. We got it. That's it. What about the next scenario? So what is the probability that I'm able to pull 2 hearts from a deck given that the lost card now is a club? Well, I've still got the same and statement. So I've got 51 cards and then 50 after I pull, right? So, but here, okay, the card is a club. So what's the probability that I'm going to pull a heart? Well, they're all still intact, right? And then the same thing here. And this should be equal to my probability of a B3 and my probability of a B4. So I can plug in everything in my expression here. Excuse me. Whoops. I can plug in everything here in my expression and we can find that probability. So this is a powerful tool and technique, especially when you're working and being given multiple scenarios that can be occurring here. So the Bayes theorem is very, very powerful. It really, really kind of, you have to take it step by step and step. And when you read the statement, break it down into, again, what information is being given, and then what is being asked, and then what are the other possibilities that can occur in that statement. So it's it can be very complicated. It really depends, or it really is incumbent upon us to break down, be careful of verbiage, and then translate that into kind of our mathematical language. And don't worry, you'll have lots of practice on your problem set. And we'll see you all next time. Thanks. Bye.